All right, so today we're discussing lesson 6.4. I'm going to talk about the slope-intercept equation for a line. And so we've actually already been using this equation. If you look at the big idea, the line that contains the point 0, comma b, we'll get back to that in a second, and slope m, we already know what slope is, has this special equation y equals mx plus b. So that's obviously familiar because we were using this equation to find slope. And so now we're going to take it one step further and use it to find the y-intercept. So letter B represents the y-intercept. That's part of a point 0, comma b. And so what is that? The y-intercept is the y value at the point where a graph crosses the y-axis. The y value where it crosses the y-axis. So if I just draw a line on this graph, where does it hit the y-axis? Well, right here. And it hits it at a point. And that point, since it's on the y-axis, is going to have an x value of 0 because I'm not going left or right. And then something. And we're going to put the letter b in there for now. That's the y value, though, of the point where a line crosses the y-axis. So let's say this was -2. It would be 0, -2. So in our equation, the b would be a -2. So the slope-intercept form is y equals mx plus b. We know that. M is the slope, which again, remember, this would be a negative slope. That shows, is it going down? Is it going up? It's the rise over run. And b now, we're going to talk more specifically about is the y-intercept. And again, that's the y value at the point where a graph crosses the y-axis. Now, one special case that you are going to see in your homework that you want to be aware of and just understand the vocabulary for it is direct variation. And the textbook definition says when y is a constant multiple of x. Well, a multiple is when you're multiplying x by something. So multiples of 5 is 5, 10, 15, 20. Okay, so let's say the slope was 5. Y is a multiple of x. 5 times 1, 5 times 2, 5 times 3 gets you y. But if you look at this equation, y equals mx, what's it missing? It's missing the plus b. So when does this happen? This specific case, a direct variation, happens when the y-intercept is 0. So there is no plus b or minus b or anything like that. It's just the slope times x that gives you y. So it's a constant multiple of x. You will see cases of that in your homework, so refer back to that when you get there. So example number 1. We're going to look at these equations that are not in the perfect slope-intercept form. How do we get them there, which we've already practiced, so that part we'll kind of go through quickly. And then once we've done that, we can state the slope and y-intercept from that form. Okay, so y equals mx plus b. We got to get it there, which means y needs to be isolated by itself. So in this case, I have a 2x plus y. I need the 2x to go away, so it just says y equals everything else. I'm going to go quickly because we did this already in the first part of chapter 6. We're going to get y by itself by subtracting 2x. So I have now y equals, which is what I wanted. And now everything's on the other side. Now earlier in chapter 6, we said it really doesn't matter how you write this on this side. I always tried to put that x up front, but you could have wrote 6 minus 2x. We really want to try and get this in this standard form. And so we really do want that x up front. It's not completely incorrect to write it the other way, but we are really going to focus on getting it into this standard form. So that's what I'd like you to try and do. So since this is a minus 2x, we can think of it as a negative 2x when we put it up front. And since we still have this positive 6, we know positive is always represented as a plus in these types of equations. Okay, so I'd like you to try and put it in that standard form instead of writing 6 minus 2x. They are equivalent, but let's try and get it like this. So once y is by itself, I can identify my slope, which is our m, and our y-intercept, which is our b. So our slope is -2, and our y-intercept is positive 6. Now, whenever we do an easy one like this, students always say, couldn't I just figure that out by looking at the original? Now, this is a very simple one. Here's the 6, and the 2 just becomes negative when I move it over here. Now, because this was such a simple, just little one step to get it there, you can kind of see what the slope and intercept are ahead of time. But I must warn you, most of the time, when it's not that easy, that's not the case. And you'll see that right away on this next one. So students want to say, well, isn't the slope then going to be -2 and the y-intercept 3? No, it's not. So let me show you why. So what we want to do is we want to get this y by itself. So we've got all of this to get rid of, starting with the minus 2x. So it's going to go away. Now the minus 3y stays. And now practicing our standard form, we're going to put the x up front. Since we subtracted it, it's like a negative 2x. And since this is a positive 3, it's plus 3. Now, if the y was by itself, then sure, there's your negative 2 slope, there's your 3y intercept, but that is not what we have here. We need to get rid of this coefficient of negative 3. Since it's being multiplied, we divide to get rid of it, and that changes everything. So this goes away. Y is now isolated, but what do we do with all this division? So we know two negatives when you divide make a positive, so they go away. 2 divided by 3, not a great number. We've already practiced keeping this a fraction. Slope is often expressed as a fraction, so we're comfortable with that. 2/3 x, there's your slope. What about this? So this is a positive divided by a negative, so it does create a negative, so we're going to write minus. If you write plus, negative, whatever, that's okay, but it is better to have it just as a minus. So since we divided these and got a negative, we're going to write minus, and 3 divided by 3 is 1. Okay, we've got this in standard form. Going back to what I was talking about earlier, if you just looked at this and you said, well, the slope's going to be negative 2 when I move it, intercept is 3, take a look. It's not even close. Okay, so we can't fall into that trap. We do need to do this rearranging. The slope is whatever the coefficient of x is, so 2/3. And the y-intercept, where this line is going to hit the y-axis, be careful, the minus tells you this is a negative 1, not a positive 1. And if you think about how important that is, it's where the line hits this axis. Negative 1, positive 1, big difference. Okay, so we need to make sure we understand if it says minus, it's a negative. If it says plus, it's a positive. Okay, to the next one. Now the y is on the right side. We're still going to move everything away from it. If you really wanted to rewrite this, you can always flip-flop an equation. So if you wanted to take the negative 9, put it on this side, 3x plus 6y on the other side, you could. Okay, but we're just going to work on just isolating that y while it's already on the right side. So if I'm going to clear everything away from it, I'm going to start with the x, just like I did when the y was on the left side. And so now I have a 6y still hanging over there on the right side. And I want to put this in the right order, x up front, negative 3x. And now I have a negative 9. I'm going to write that as minus 9. Okay, y is almost isolated. I need to divide by this 6, though. Everything gets divided by 6. Y is isolated. It's on the right side, and that's okay. Now let's walk through what this is going to look like. So this is a negative divided by a positive. So first of all, that's going to give me a negative. And 3 divided by 6 is 1/2, not 2. You get 2 from 6 divided by 3. So 3 divided by 6, it's a fraction. Divide them both by 3, and you get 1/2. So negative 1/2 x. This is a negative and a positive, so also going to produce a negative, which we write as a minus. And 9/6, not going to divide nicely. We leave it as a fraction. But 9/6 can be simplified, so we should divide them both by 3, and you get 3/2. So you can see this doesn't look anything close to what it used to. So our slope is negative 1/2. So on the graph, it's going down 1/2. And we know it's going to hit that y-axis at this point, negative 3/2. So it's not going to hit the y-axis right perfectly at a nice whole number. And realistically, that's what's going to happen a lot of the time. Okay, it's not always going to hit at a nice whole number. All right, last one. Here's my y. Let's get rid of this. Now, this is the first example where the x is a negative, so that means we're adding to get rid of it. So minus 4x, we got to add 4x. So 2y's left over. Positive or plus 4x goes up front. Positive 8 plus 8 goes there. All we got to do is clear this out, so divide by 2. All positives, don't have to worry about any negatives. 4 divided by 2 is 2x. 8 divided by 2 is 4. So my slope is 2 and my y-intercept is 4. So all this work, very similar to what we were already doing before to find the slope, except now we're also going to identify the y-intercept. So how is that useful? What's the point? Why are we even talking about this? Let's flip to the other side and see how we can use this. So when we get to example number 2, they're going to give you an equation of a line, and we're going to identify the slope, identify the y-intercept, and then how can we use that information to put this quickly onto the graph? How can we draw this line from just the equation? So let's identify slope and intercept for every single one. That's the first thing we're going to do. And then we'll go back and graph them. So slope here is 4. Y-intercept is 2. Slope here is -1/2. Intercept is 4. Slope here is 2/5. And now I don't have a plus or a minus anything out here. That means my y-intercept is 0. It's like writing a +0 here. It doesn't change it, but we don't need to write it. But it really is a +0 or a -0. So our y-intercept is 0. Okay, so now let's get this on the graph. How can we graph this with just this information? So in a previous unit, we had a point and a slope. And from that point, we could use the slope, the rise over run. So this slope is 4/1, which is actually the rise and the run. So from a certain point on the graph, we would use this and go up 4/1, up 4/1, and there's our line. So we're not given a point, but we are given a y-intercept. So in essence, we actually are given a point because the y-intercept tells me where this line crosses the y-axis. So it's at 2. So right here, because this is 2, that point right there is where this line is going to hit the y-axis. So what is that point? That point is actually 0, 2. So I have been given a point. When you have the y-intercept, you actually do have a point. And I have the slope, which tells me I'm going to go up 4/1 from here. 1, 2, 3, 4/1. I'm going to go backwards. It's down 4/1 this way. And very quickly and easily, I can graph a line when it's in the form y = mx + b. Let's go to the next one. The point that this hits the y-axis is at 4. So that's like the point 0, 4. 1, 2, 3, 4 hits the y-axis at 4. Now it's got a slope of -1/2. So that's your rise and run. Negative means it's going down 1. So down 1/2. Down 1/2. You can go as many times as you want. And if you're going to go the other way, up 1/2, up 1/2. Just remember when you're using the original slope, it's always to the right. You go down to the right or you go up to the right. It doesn't matter if it's positive or negative, you're always going to the right. Connect your dots, ideally with a straight edge, but if not, just be careful with it. And it looks like that. All right, now let's deal with the last one. So there was no y-intercept given in the equation, so we talked about it's 0. So where does it hit? Right there in the middle. That's 0. That's the origin. So anytime we see an equation like this where it just says y = something x, we know it hits at the origin. All right, and then from that point, that's the point 0, 0. Notice the y-intercept always has an x value of 0 because that's where it's hitting the y-axis. We're going to use the slope now and go up to over 5. Rise, run, up to, and the run is always to the right, up to over 5. Going the other way, down to over 5. And there's my line. So if you have the equation given to you in y = form, very easy to put it on the graph. And from the graph, you could identify a bunch of extra ordered pairs that'll work for this equation. All right, last one, word problem. How can we relate this? So a skydiver opens a parachute and he's falling. Think about what that looks like on a graph already. Falling, negative slope, at a speed of 10 feet per second. And where's he falling from? 5,000 feet above the ground. So he's starting at 5,000 feet. That's your starting point. And he's falling 10 feet per second. 10 feet per second. So every single second, it's another 10 feet, 10 feet. So what is the slope? Remember, slope is like the rate of change. And so the slope here is represented by the 10 feet per second. That's how much it's going down every single second. That's what slope tells you, how much it's going up, how much it's going down for every one something. So since we're falling, we need to make sure we represent this as a negative. And so my slope is negative 10. So what's the y-intercept? Well, I'm sure we could just guess it's 5,000, but why? It's where you start. Okay, we're starting at 5,000, and then it's dropping, dropping, dropping all the way till you hit the ground. Okay, so our y-intercept is 5,000. So write the equation. So if we have the slope and we have the intercept, we can just plug this right into an equation. So y equals mx plus b. Rewrite it with these numbers in there. So y equals, instead of m, it's negative 10x. And instead of plus b, it's plus 5,000. Now, we wrote these equations in middle school. Here's your constant. You're starting at 5,000, and then it's changing by 10, negative 10, every whatever, in this case, every second. So x is the number of seconds. And so we're basically taking 5,000 and subtracting a multiple of 10 for how many seconds it is, and that's going to give you y, which in this case would be the height, or how far up it is. So let's make sure we understand what this is. Y is the height, x is the seconds. Last but not least, let's use the equation to find the height of the skydiver after 5 minutes. 5 minutes. That's 300 seconds. Now, it's nice that it gave it to you, because a lot of people would have just took 5 and plugged it right in, not thinking. X is seconds. So 5 minutes is 300 seconds. So we're actually plugging 300 into x, because x represents seconds. So we're going to take our equation, and we're going to substitute. So y equals negative 10. We're going to plug 300 in for x. Oops, and that was 5,000, not 500. So let's see what happens. When I multiply this, I'm going to get negative 3,000. Think about what that does. So you were at 5,000 feet above the ground, and 300 seconds later, you're going to be 3,000 less than that. So that's why this is going to be a negative coming off of the 5,000 that you started at, leaving you at 2,000 feet. So you can see this is an equation that we've looked at before, but we haven't specifically identified the slope and the y-intercept. And you can start to picture what this is going to look like on a graph. It's going to hit the y-axis all the way up there at 5,000 and just drop, 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 drop by multiples of 10 all the way down until you hit the x-axis, which would be the ground.